Good afternoon, everyone, and thanks for coming to this seminar. And it's our great pleasure to invite Professor Javed MOSTAFA from University of Toronto to give us a talk. And this seminar is co-hosted by the site and our unit, MST. And let me have a brief introduction about Professor MOSTAFA. And he is a professor and the Dean of Faculty of Information at the University of Toronto. And his research focuses on multimedia information retrieval, personalization, and user modeling, as well as cyber infrastructure for research and learning. And Professor MOSTAFA came to University of Toronto in September 2023 from the University of North Carolina at Chapel Hill, where he served as a professor and the founding director of an interdisciplinary informatics training program called the Carolina Health Informatics Program that oversaw collaboration among 7 UNC academic units. And previously at Indiana University Bloomington, Professor MOSTAFA held the Victor ZHANG endowed professorship, and he also served as an associate dean of the academics and an associate dean of research. Professor MOSTAFA completed his PhD in information science at the University of Texas at Austin in 1994, with a focus on developing information query models and search interfaces for video information. With more than 105 peer-reviewed publications of his own, Professor MOSTAFA has served in editorial roles for several prestigious journals in the field. He was the editor-in-chief of Journal of the Association for Information Science and Technology, an associate editor for the journal ACM Transactions on Information System, and currently serves as an associate editor for the journal ACM Transactions on Internet Technology. At University of Toronto, he directs the Laboratory of Applied Informatics Research. He is also the co-founder of 2 US-based companies, Kino Health and Semantics. So let's welcome.
Hey, thank you so much for your kind introduction. And so today I will be talking about a project we refer to as HDX or Health Data Exchange. And it is a project that aims to create a online resource and an online community around research analytics and research informatics for supporting clinical and healthcare research. And it has been going on for a while as part of my efforts started in North Carolina, and I'm continuing this in Toronto. And around this project, I'd like to discuss some specific areas that touch on just developing large-scale online resource for learning and research, and how to think about those challenges and how to address them. So I will start with the introduction and why do we need data exchange? What are the goals for developing such an infrastructure and system? Then get into a bit about the system architecture, and then also talk about many of these kinds of efforts often are created with a lot of funding, millions of dollars from government and private sector. But a big weakness for these kinds of projects that are especially created in public sector, usually nonprofits, NGOs, or educational institutions, that they run for a few years and then they disappear, or there is no sustainability model. They don't know how to maintain and grow. like we see in private sector. So sustainability to me is a big challenge, and we have to learn how to sustain these kinds of large projects. And I will talk about something called a FAIR principle, which goes into sustainability in a bit more detail. And we'll talk about metadata and annotation and some of the preparation for making a system FAIR compatible. And then we will end the discussion with a summary. By the way, at any point during my discussion, my talk, please feel free to ask questions. And if you don't understand something, I will be very happy to stop and try to explain. I don't want to just keep talking. So one of the, obviously, the challenges of the day is this booming and explosive growth in data. And we have colleagues that have done some research on, you can go to this website and find more information on just assessing how much data being generated today. And you see the numbers there, 2.2 exabytes currently per year, which 1 exabyte is roughly equal to 1 billion gigabytes, and 1 gigabyte is about roughly 5,000 books. And of the total, interestingly, volume of data being generated, such large quantities, about 30% of the data come from healthcare. Okay? And that is about 0.7 exabyte, which is roughly about, will really approximate eventually by the end of this year to about 1 billion gigabyte at this current growth rate. So that's a lot of data that get generated from healthcare. So do you think is the largest, most complex data that get generated in healthcare that you can think about?
Genomic.
Genomic data? Or any other type of data in healthcare, which is very large?
Image data.
Image data, yeah. Anytime you do an MR or a CT scan, those are very large quantities of data. That's why healthcare data is so voluminous. And it turns out among the major industries, financial, media, entertainment, manufacturing, healthcare data grows at a faster pace than any of those industries. So the volume production for that industry is very rapid, very fast, and it's contributing to this data storm, if you will. Okay? And interestingly, to do any type of modern AI, machine learning, analytics, of course we need access to the data. But it turns out among the major industries, healthcare data, shouldn't be a surprise, is the most sensitive in terms of governance, rules, regulations, barriers to access. Healthcare data present many types of challenges. And to the point where we usually run into these challenges from accessing data from one organization to another organization. But even inside one organization, sometimes it's difficult to get access to the data to be able to do analytics and to be able to do even research. So this is one of the big reasons to think about how do we organize data, healthcare data, in a way that promote better access, easier way to analyze that data, and be able to share the analysis and what we learn from that data. And so we know that data analytics, basically all the hoopla, all the excitement you hear about analytics and machine learning and AI today require, guess what? Data. So, and if you make access to data difficult, you're going to make creating advanced techniques, methods, and solutions to solving healthcare are different, right? This is the big reason to think about data analytics and machine learning and its relationship to data. And when you need to do these kinds of things, you need access to data. But interestingly, when you do these kinds of work using modern machine learning analytics, they also produce new data. And there is need to maintain pre-use data and post-use data, and you need to link these two types of data to each other. So there's a lot of interesting complexities that arise in thinking about how do you create these kinds of organized, classified, well-curated resources. And by the way, healthcare is not the only industry that is doing this. Of course, there are other types of applications and domains where data have been organized, classified, and curated in very careful ways to promote the industries and to promote the research and various organizations, and we'll discuss some of them. So what are the primary reasons for data exchange and health data exchange? We just discussed the big framework. As you get closer and more specific, we need to create these resources in a way so that we can gain access to them in a consistent way. So every time we want to access, we don't need to figure out, oh, how do we do this again? We can use the same method, same techniques over and over again. Every time we need to access data, we don't have to remember where do we go to access the data? Has the data moved? So that's called persistence. Okay. Data need to remain in places so we don't have to remember where they are. We need to be able to access data using standardized methods so that we are not just creating a new rule or a new protocol or a new technique. Everyone knows that standard, so they can rely on the standard to be able to access and use the data consistently as they need. We need to maintain the data with the right regulatory and governance framework, more important for healthcare, because if we cannot give confidence that we are maintaining privacy, we are maintaining security, then we won't be able to share that data. People will not trust us. Okay? So we need to understand the regulatory, the governance around that access. Finally, those systems that we build and the resources we build have to be sustainable. This is something very important to me and increasingly important to my lab, to my students when I teach them. And it's almost become a mantra for me. This is the reason why all of us are guilty, especially the faculty here, which is our government, our industry partners give us money, we do a project, we generate data, and after the grant is over, you can't access the data anymore. We write papers, we publish, our research friends and peers tell us, oh, that's a very interesting research you did. Can you share the data with us? Oh, sorry, that PhD student left. This is sustainability challenge. Okay? And we need to learn how to sustain the resources, especially data, increasingly important to our research. Forget about all the other things we generate. At least the data we have to maintain. Increasingly also important in the US and North America. I think it's also important here. When you publish now, you have to source for certain journals. You have to maintain your data set because they would require you to provide access to your data set.
Otherwise, you won't be able to publish it. When you apply for grants, in some cases in the US, you need something called data management plan that you have to provide with your grant. Guess what? To solve the sustainability problem that I just described, it's still not fully solved because we haven't adopted it in our practice. So we will begin to see how we can do that. Okay? So, why health exchange? More reasons. Post-analysis, post-research, data still has value. This is what I just described. Publication, dissemination require access to data. You need to be able to point to when you kept your data, when you submit a manuscript. Why? One of the mantras, the core principles of scientific research is your research should be replicable. When you publish something, someone else should be able to pick up and do that work and be able to generate the results, more or less similar results that you have done. This is the basic principle. But if you can't even provide access to your data, how can they replicate your research? We need data post-research, post-analysis for teaching, for pedagogy, so that if that method becomes adopted, widely understood, used, known, we need to teach that method. Guess what? We need access to the data sets. We need to do sometimes not just one-shot research. We do research, we publish, we have data set. We want to do further research in that same problem area. We want to scale up our research. We need to maintain the data set. And we need to develop a way to build networks of peers and collaborators and teams. Research these days is not a solitary, single person, single investigator matter. Most research, complex research, even in social sciences, increasingly are team-based. Well, guess what? For team and community level access, you need to maintain it in a place where everyone can access it and use it, right? So, major goals of HDX. We need to develop these kinds of complex systems in a phased way. We need to be iterating over that design, and we need to sustain that system. Let's go through some of these dimensions called requirements for this system. So we need to support researcher. One of the primary key function or feature that information science teaches you, sometimes we forget, is before you can even search for relevant items, you have to know where to search, what to search. That's not access problem, it's called the findability problem. Right? If you have a question that you want to answer, first thing you have to know is which database has the answer and where is the database. After you find the resource, then you can get into, oh, now I know this is the system and this is the way I can search. That's comes after. So you can create these data resources, but if people can't find them, they might as well not exist. How do you solve the findability gap? It's not easy, but you have to know that that is a gap. It's just creating the resources not enough. Making the system easily searchable, not enough. The resource should be findable. Accessing, of course, once it's found, what's the best way to search it? Using the data. This goes beyond finding the data. See, it's not just a typical literature retrieval system. It's a data retrieval system. And often people retrieve data not just to browse the data, but to be able to do something with the data. to apply some tools and techniques and methods. What does this imply? You need to bring the tools and methods and techniques closer to the data. You have to support software. See, often we think about databases as just cylinders and storage for data. Increasingly though, most systems that are new systems in other domains that are being created have not just data, but they also have the software together, linked in a way so you can find the data and then find the software. Or you can find the software and find data. Okay? You need to think about it like that. We need to make sure that data access and software access and resource access is secure and auditable. We need to support what happens after the analysis, after the access. How do I disseminate the results? Remember, post-use is also very important. We need to take contribution of data from researchers, meaning we need to not just create a system with existing data, create a system that allows researchers to contribute data and update or retire the data. Okay. Sustainability brings lots of other requirements. Okay, community building. Imagine a system, a database that's so cool that you not only can access the data, but you can access the data and ask the question, who published papers using this data? And what papers have been published? Imagine that. Today, when you find published papers, you can hardly find papers. Forget about hardly find data. Forget about finding papers from data. I'm not just creating these requirements. I'll show you systems that already do that. And we need to learn how it's done and how we can adopt those principles. We not only want to find publications, we want to find a publication and ask the question, what other publications are related to this publication? We can do that in Amazon today. You can buy a toothpaste and then you see all of the other toothpaste that are related to this toothpaste with different kinds of attributes and dimensions. Why can't we find a paper and say, what are other related research papers to this one? That's called linking publications. Linking publications to researchers. Then we need to build tools for sustainability with data, publications, community. How do we then use this to teach, to train? We need to partner. When we create these kinds of data exchange tools, we need to partner with major partnership with related organizations like publishers, nonprofits, and other organizations to be able to sustain. Okay, any questions so far? I've given you all kinds of abstract, almost conceptual requirements. Now the time has come to see some real-life examples. You may be thinking, what are the systems that don't even come close to doing some of the things you're talking about? Questions?
Just a comment, yeah.
Yeah.
I just find it interesting that so in around 1991,
Yeah.
so 34 years ago,
Mhm.
I was working at the data library at UBC Canada, and my job was to make the data more fundable for our users, professors, researchers, and students in the university. Yeah, and after 34 years, we're still talking about this findability of data. Very interesting.
I'll just give you one example related to that. You have a major library at University of Hong Kong, I'm sure, right? This is my challenge to you. Okay? Go to the library page, then ask how many databases does the library provide access to? I'll just take a very conservative number. I will say at least 40, 50, maybe even 100 or more databases. You will see the list of databases, okay? And they're sorted, organized, if it's managed well, by topics sometimes, right? But you go, my challenge to you, go inside, keep going, open one of those databases, open it up and try to search. You will say, what country is this? Do I need a passport? This seems so alien to me. This doesn't look like anything I normally search. I don't know what you normally search, by the way. But you know, every one of those databases, you know how much it's cost the library to create a partnership and pay for that vendor? Now, step back and ask, if this is so difficult to find the databases and then to search, well, how come our university is paying? And I don't want to create trouble for whoever managed the library. You know, these systems collect transactions. Every one of these systems are trackable. Like how many people are searching, what are they searching, how many queries are being generated, where are they being generated from, even which building, which department, right? This is my challenge to you. You want to do a dissertation that will change the world, then just do that. That's called findability. You ask a freshman who's walking downstairs, say, hey, you got an essay assignment today. In your biology class, you have to do this research and you have to write a report. What databases will you search? Do you think they will know? Absolutely not. You know what they are told if you walk to the library? Hey, go to the library page. There are many databases. Do you think they will be able to actually find the database? Probably not. And if they find, good luck, if they can actually search it. Do you think these problems are mundane? They seem simple because I explain to you in simple terms. Sometimes people confuse simple way of explaining and understanding with a simple problem. It's not a simple problem, believe me. If it was, it would have been solved by now. But as a professor who's been teaching for 30 plus years, I see a compelling problem and I say to my students, that's a compelling problem. Just solve findability in this context, you'll be famous. Here is the picture I wanted to share with you. This comes from one of the largest databases in the world. And it's public. By the way, it's free. Free to the world. What is this? NCBI. National Center for Biomedical Information. This is supported by PubMed and the people who developed the database for NIH. Why is this system so fascinating? Well, look at the system. Look how many different types of data they have. This is all biomedical, right? But look at the different types of data they have. They have human genome, they have proteins, they have something called literature. That literature, by the way, I think it has at least 25 to 30 million publications today. It's the largest biomedical database in the world. But what is interesting about this picture, about this system, is all of these different databases are linked to each other. Why is that important? Well, you are interested in cancer, and you want to understand what genes contribute to certain types of cancer. You can go from the gene to the publication, one specific gene, to the research associated with that gene. You know, certain genes are responsible for breast cancer. They have known that. Knowing the genes, you can find the research. Knowing the research, you can find the genes. They're all interlinked. And that curation, that connection has been already made for you. This is the vision. This is the type of data exchange I'm talking about. You may say, Javed, then the discussion can finish. There is already a system. Why are we talking about it? But this is only for biomedicine. Healthcare is a lot more than biomedicine. Healthcare has clinical data. Remember those images that we just talked about? None of that clinical data is here. The type of data I'm talking about are being generated by hospitals. The individual population level data, the community level data, the environmental data, the demographic data, the social determinants of health, none of that is here. So even in the big health space, there are gaps. And what I'm suggesting, we need to create open tools, open resources like this one to promote and support healthcare using principles like this one. You can submit data, you can download data, you can develop tools and software using the data, you can analyze the data, you can conduct research using the data, you can even incorporate those data and tools in teaching and learning. Here is another example. It's called N3C. This was developed also by PubMed and NCBI, but this was only developed during the COVID to promote and speed up research around COVID. And look at the tools that they support. They support access to platforms and data analysis tools. You can then, once you find data, you can browse the data and data tables. You can use vocabularies and terminologies called concept browsing to find data. You can also share notes with each other. Researchers who are using this data set, you can share notes with them. That's the community building part. And this is called National COVID Cohort Collaborative, N3C. And this is a very interesting platform because it has some really powerful way for curating the data and the tools that the system uses. Sorry for the complicated picture, but this is a very important behind the scene process that's happening to curate the data. These are the tools and systems being used and the workflow being used. So remember, this is COVID data set, right? So we only want patient data that have shown COVID symptoms or are suffering from COVID We don't want data from patients that have other diseases. And so there is something called phenotyping that needs to happen at the individual record and data level. So this term phenotyping is very important in healthcare because not every disease can be deterministically, easily, accurately identified just by looking at the clinical record. Just because the diagnosis says COVID, it's not 100% this person has COVID. You need to look at the data, the clinical record comprehensively and carefully. That process of comprehensively, carefully, precisely determining a specific symptom or disease is called phenotyping. Okay? So that requires human intervention and machine intervention. So that's just the first step. After you determine the records to belong to COVID patients, then you run it through this process. This is the internal process. This is called extra transform load, ETL. And you're doing that to clean up the record and prepare the record for submission to the national level. But you need to convert the record to something called Common Data Model, CDM. Remember standardization? I said that you need standardization. This process is therefore really important. And then you submit it to one of the national systems that are 4 of them they provided. And from there, the record is ultimately transferred to the central system, where it goes through another layer of ETLing, extra transform load. Because the records are coming from multiple sites, they need to be combined, staged, and combined into a CDM model, common data model, and then transferred to a production database called the Unified CDM. And from there, researchers can then access this data set using something called a secure enclave, secure analytic enclave. So this model is very useful to kind of think about data exchange systems. So let me go a bit faster. So goals for the HDX is resources need to be found quickly, easily. Accessing resources to be searchable based on standardized terminologies and common words. Retrieve results should be easily browsable, understandable. Use results should be downloadable. Tools should allow the user to analyze. Output should be easily storable, recoverable, and shareable. Allow contribution of new data and retirement of data. Community support finding the contributors and producers of data and communicating with them. Supporting tools for identifying teams and building team-based approach for research. Provide tools for conducting online learning, meetings, access to resources, and general platform for large scale, sometimes cross-organization, cross even geographic location collaboration. And we need to build these systems for teaching and learning to make sure that these systems continue to be used. So the architecture, you can think of this at 3 levels. Users can enter through a community, users can access data, or begin to use the data. Users can use software with the data and then contribute new data and build software for connectivity with the data using application programming interfaces or APIs. And the layers are described here. Some of the standard APIs in healthcare, for example, is HL7. FHIR is common for accessing data in a standardized way. And these kinds of data exchange systems have to allow programmatic access. So here's a bit more detail about the data catalog. So when we build an HDX, it'll have data on different domains of healthcare. But when you have databases that are domain specific like this, when a user searches for data that cross domain, we have to be able to do something called crosstalk. Crosstalk is facilitated using universal domain language or ontology. In medicine, there is one called Universal Medical Language System, UMLS, for example, that allows these kinds of cross-domain searches. Here is another layer. Just for cancer, you can have different types of data in the data catalog, right? And going further into the architecture, this is really important, this slide. How do we use software with data? So data, different types of data are coming in. We need to first layer them into specific types of data. This is typical clinical predictive modeling pipelining. We want to do risk prediction on patients. You need all these types of data today to be able to do risk prediction. Starting with clinical records, lab results, including demographic information and access to food, transportation network, etc. Once you build this, then you can ETL them, get all of the key features extracted, placed inside a data mart, and now we are ready to do analytics. We can use different types of analytics methods to do risk prediction. This whole pipeline needs to be supported in a data exchange platform. And we've actually developed a system like this for a past project. So here is another way to access data through the community approach. You can search for data or software and find data. You can search for people or organization, find data. You can also post something in social networks, other people post something and link to data. If you go to GitHub today or go to Kaggle, you can see things like this happening already. Accessing to data through community discussion, right? And you can even message individually to users who are belonging to this community. And then ultimately, the idea is to get access to the data layer, which are linked to all of this. So just thinking about a data system, imagine a library catalog which functions like this. You probably won't see a library catalog that functions like that. Again, because the vendors want to restrict access. Okay? And they will probably release one in 4 or 5 years, but will charge you 10 times more. Again, you want to make a name for yourself, begin to think about databases not just as static sources for records, but as an anchor for communities. By the way, it's already happening, but in other domains. As I said, you go to GitHub to search for software and data sets you can find. You can go to Kaggle for machine learning. You can find communities and exchanges and interaction. Why can't this happen in scholarly educational context, right? Why is it only available for software developers? Because they're smarter? I don't think so. So user community provide organization domain-based directories for the community, support discovery for other researchers and experts who have association with data sets, allow users to identify relationship between domains, fields like cancer, to researchers using the data sets as a bridge, support functions such as postings of messages, blogs, comments, We should be able to do that, right? You take some papers from a system and you say, I found these papers to be especially useful because I was doing this kind of research. Imagine finding those things, and then you can probably not only find resources that are relevant to you, you probably can find some really good friends while you are in the university who share similar interests. So user community can be built in other ways, other more formal ways, because in machine learning and AI, we have a very important need to have gold standards, data sets that are curated against certain types of techniques and methods to produce certain types of results, so that we can test any new methods or techniques or evolution of methods we create. So those gold standard curation can be really powerful to keep drawing new people to your system. And there are some really nice examples. I mentioned one, but this is the one that I like. This is maintained by National Institute of Standards and Technology in the US called TREC. Sometimes people refer to TREC as the grandmother of data, gold standard data sets. Here's the website. You can go check it out, especially if you're interested in information retrieval and information science. This is a really important resource, and you can learn a lot from it. In terms of the history, this is about 35 to 40 years old. This goes back, of course, many years, and it's still being maintained and supported. So sustainability also requires forming these kinds of important partnership because the research produces new intellectual property, licensable technologies. They need to be somehow aggregated and connected to your resource. And you can even think of your HDX or data exchange as a nonprofit that you want to sustain and grow. So finally, I want to talk about this FAIR principle. FAIR was developed in 2016 to promote scalability, sustainability, by using some rigorous principles like finding and discovery, accessibility, interoperability, and reusability. And these principles now are quite widely known and used for data management and data resource creation. And here are some examples of steps you need to take to make your data fair. You need to work with unique identifiers to make data findable. You need to use standardized vocabularies for terminologies for accessibility, and you need to follow standard, secure, and reliable protocols for access. Here is a template. Here is a URL to make your data fair, compatible, or sometimes called verification of your data set. And you can see the steps in this template, and they also offer you specific milestones to follow. Okay. And finally, the summary. We need to have our data, software, and people aggregated. We need to make things findable, accessible, and sociable in terms of usage of that system. We need to make our software pipeline transparent and easy to use. We need to grow and maintain these systems, and one way is to support FAIR principles. Thank you very much.